Alright, so now I'm going to be talking about LeetCode problem number 2462, which is total cost to hire K workers. And this is marked as a medium level problem on LeetCode. So let us first go over to the problem statement, and then we'll get to the examples, and then finally the coding part. So you are given a zero indexed integer array costs, and where costs of I is the cost of hiring the ith worker. You're also given two integers K and candidates. We want to hire exactly K workers according to the following rules. You will run K sessions and hire exactly one worker in each session. Okay. In each hiring session, choose the worker with the lowest cost from either the first candidate's workers or the last candidate's workers. Now, candidates is actually an integer, as you can see here. Break the type by the smallest index. So basically, for example, if costs is this array and candidates, which is an integer, is given as 2, then in the first hiring session, we will choose the fourth worker because they have the lowest cost. Let me just draw and show you how it is working. So this is the example, right? 3, 2, 7, 7, 1, 2. 1 and 2. So we basically need to choose the lowest cost among the candidates, the first two candidates and the last two candidates. That is, we select these two, 0th and the first index, and the this is the 4th and 5th index. So we choose the last two candidates and the first two candidates. That is what's given, right? That is either the first candidate number of workers or the last candidate number of workers. So we basically take these into account, 3, 2, 1 and 2, and we check from all these values what is the lowest cost. So 1 is the lowest, right? So we basically remove 1 from the array and add that to the cost. Now cost has been 1, right? In the second hiring session, since k is equal to 2, we will choose the first worker because the same lowest cost as the fourth worker is going to be 2. Let me show you. Now since we have removed 1, right? So let it reset. Yeah, so now we have removed 1 from this vector. So now the vector becomes 3, 2, 7, 7, 2. So now again we consider the first two candidates and the last two candidates, and now you see the lowest cost would be this one and also this. But now since there is a tie, we will choose the lower index, that is the index marked as 1 instead of the index marked as 4. So that is why in the second hiring session we choose the first worker because they have the first means the index, that is not the 0th but the first worker, because they have the same lowest cost as the fourth worker but they have the smallest index, that is this one. Please note the indexing may be changed in the process, right? Obviously because we are deleting elements, the lowest cost elements, so we have to change the index as well. Now if there are fewer than candidates workers remaining, choose the worker with the lowest cost among them, break the tie by the smallest index. Okay, and a worker can only be chosen once, right? And finally the answer would be the total cost to hire exactly k workers. So that is the problem statement. Now let us get to one example. Now I'm going to be solving the example 1, which is going to be our which will basically give you a complete insight into how you're going to be approaching this problem, right? So this is the costs array, k is equal to 3, that is we have to return the total cost to hire exactly 3 workers, 3 minimum cost workers, right? So that is going to be our condition, that is 3 top the minimum cost workers, and candidates is given as 4, which means we have to consider the 4 candidates from the first from basically the beginning, and 4 candidates from the end of the array, if this is the array given to us, right? So we first we have to hire 3 workers in total, so the total cost is initialized as 0, right? So let us say cost is 0 because that is the initial cost. Now we consider in the first hiring round we will consider, just a second. So in the first round we will consider the 4 workers from the beginning and the 4 workers from the end, right? So from among these, if you see, you can see the lowest cost is 2 in the front as well, you can see, and in the from the back selection as well, you can see that there is 2 present here. So we obviously chose the lower index one, so we basically pop this one out, right? So the lowest cost is 2 here as well, and we break the tie by the smallest index, which is the index is 0, 1, 2 and 3 is the index which is present here. So the total cost is now updated to 2, and 2 is removed from this array, right? So this is removed. So now the new array becomes 17, 2, 10, 7. This will be removed, and then 2, 11, 28. So now again we choose the first 4 and the last 4, right? So as you can see, the first 4 will be 17, 12, 10 and 7, and the last 4 will be 2, 11, 2, 20 and 8. So now you see that one worker has been selected. In the second hiring session we would select this 2, which is the smallest cost. So we again add update cost with the 2 more, that is now it becomes 4, and remove this 2 as well. So now these 2 2's have been removed again, and now we basically have the third hiring round in which we choose the worker from this 17, 2, 10, 7 and 11, 20, 10. Now the lowest cost would be 7, that is index 3. So now the cost would be updated to 4 plus 7, that is 11, right? So that is the answer. So notice that the worker with index 3 was common in the first and last 4 workers, right? So basically the workers has now 7 elements total, but the candidates we have to choose 4 plus 4, right? So 4 from beginning and 4 from end. You can see that 7 is the common element. So in that case also you have to basically choose wisely and get to the answer, that is the minimum cost. So we choose 4 plus 7 and get 11. So that is basically what is happening in this problem, right? And similarly, you can go over example 2, which is a similar one. So now let us go over to my solution. So basically what we are going to do is we are going to maintain 2 minimum heaps to track the front and back. And the intuition is basically the challenge is to how do we always pick the minimum cost worker from either the front or the back group of remaining workers efficiently, right? So this basically screams minimum heap for both the ends, that is minimum heaps which are priority queues. So we use 2 minimum heaps, one for the first candidate's worker, that is the left heap, and the one for the last candidate's workers for the right heap. So we use 2 minimum heaps, and in each hiring round we compare the top, that is the, since we have a minimum heap, the top would contain the element with the minimum cost, right? And as you keep going down, the cost starts increasing because this is a minimum heap, right? So the maximum elements you will find at the bottom, while the minimum elements you will find at the top, nearer to the top, right? So we compare the top elements, that is the smaller cost from both the heaps, and basically we maintain 2 heaps. That this is, let us say, PQ1 and another heap PQ2. This is PQ1 is for the front candidate number of workers, and this is for the back candidate workers, right? So once we have pushed our workers into this, we compare the topmost elements of both and check from these two, whichever one is the lower one, we basically add the cost of that worker to the total and pop that element out, right? And similarly we keep on doing this till our priority queue gets either empty or we reach the number of total workers that we need to hire, that is equal to k. Okay, so that is the condition. So the approach, let us go over that we initialize 2 heaps, PQ1 front heap and PQ2 for the back heap, that is the last candidates. Then push the initial candidates into the, both of the heaps. From the left side add to PQ1 and from the right side add to PQ2. Make sure the indices don't overlap, so we'll be maintaining I is equal to 0 to basically set the pointer to the front of the array, right, from which we'll start pushing the first candidate workers, and j would be initialized to the back of the array, that is n minus 1, to be pushing into the to basically traverse from right to left from the end to basically push into the back array, that is marked as PQ2, and I would be pushing into PQ1, that is the front minimum heap, right? And making sure we don't overlap with the indices, and then we run a loop k times. So at each step, pick the smaller cost worker from PQ1 or PQ2, update the cost and increment the higher count, refill the heap from I to j depending on which heap was used, right? So that is what we are going to be doing. Now the time complexity, initial heap buildings up to 2 times candidates. Basically we're considering candidate number of workers from the start and candidate number of workers from the end. So that would be 2 times candidates, which takes O candidates time log candidates, because it usually takes, building a heap takes O of n log n, right? So heap building is taking that time. And for each of the k hires, we basically would take, we are performing push and pop operations on the heap. So O of k, that would be k log candidate amount of pushes, right? Pushes or pops. So that would be finally OK log candidates plus candidates times log candidates, right? And 2 heaps of size up to the candidates would be taking space O of candidates. So that is basically the time and space complexity. And now let us get to the most important part, that is the code part. So basically we have the total cost function of long type, which takes a vector of integer costs and k value, which is the total number of workers to be hired, and candidates is basically the number of candidates that we'll be considering from the front and the back, as mentioned in the question. So I define n as the number of as basically the size of the costs vector, which means n is the total number of employees that we are seeing in our vector, that is the number of employees that can be hired, right? And now we basically define our minimum heaps for the first candidate, that is for basically the front candidates, and for the last candidates we have PQ2, right? PQ1 from the front and PQ2 for the end. So that is both our minimum heaps. Now we declare hired is equal to 0 for the workers. We're basically going to increment hired workers. So this is basically going to check if our hired is less than k. So while hired would be less than k, till the time that is the condition, we keep on running our while loop. So that is to ensure that we have only k sessions, we do not exceed k, since we need to hire only the k workers who have either minimum cost, and if the costs are tying, that is if there is a clash between the costs, we will consider the lower index, right? And we define long cost is equal to 0. So that is the total cost, and I is equal to 0 and j is equal to n minus 1 are the pointers. I is starting from the starting of the array and j from the end of the array. Now this is our main part where we start our while loop. So while hired is less than k, that is we are running for k sessions, fill the front candidate minimum heap, that is if it is not full, that is if while pq1 dot size is less than candidates while it is not full, and I is less than j, that is the I pointer has not crossed the j pointer till now, right, less than equal to j. So pq1 we push the cost, basically the cost of the worker I. So pq1 dot push cost of I and move to the next index when we have actually covered this one, right? So we go I plus plus, right? And similarly fill the back candidate minimum heap, that is pq2 if it is not full. So while pq2 size dot size is less than candidates and j greater than equal to I, that is j has not crossed I while traversing towards the back, so j is greater than equal to I, pq2 dot push the cost of the back candidate that we are pushing in priority queue, and j minus minus, that is we will be traversing from back to the starting of the array, right? And after that we basically have to get the top elements from each of the heaps, so get the minimum from each heap or int max if it is empty, right? So if pq1 has no elements, then we set minimum element of pq1 to infinity. Otherwise if it does, we basically set it to pq1 dot pop, that is the topmost element which is going to be minimum cost. So min pq1 is the topmost element in case the size of priority q1 is greater than 0. That means if priority q1 has elements, then we set the top element as min priority q1, otherwise we set it as int max. Similarly for minimum priority q2 element, right? And then we have to hire from the cheaper pool, that is from the cheaper heap, basically whichever one we compare from either minimum pq from either pq1 or pq2, whichever is the minimum cost, we choose that. So if minimum pq1 is less than equal to minimum pq2, in case of a tie we use this equal to here, because if in case the priority queues, for example the starting priority queue and the back priority queue, in case we have some elements, like let me show you, since this is a minimum heap, let us say we have the values in this order and the minimum values are on the top, right? And let us say we have 4 2 2 again, no, let us say, yeah, let us say we have 2 again and 1. So we compare these two. So in the case of equal to, when the topmost elements are equal from basically min pq1 and min pq2, in case of the tie, the lower index element will be in the pq1, right? So lower element index, why would it be in pq1? Because when we were building our priority queues, we took the start elements and the back elements, right? And in pq1 we basically pushed those elements that were at the beginning of the array. From pq2 we were sending elements that were from the back of the array. So evidently in pq1 we will have an index, which is of a lesser value than the index of value of pq2. So for example, if one was placed here and the one another one was placed here, so when we were pushing into the pq2, we pushed it because it was present at the back of the array. That means the index of pq2 in any case would be greater than index of pq1, right? If you agree with that, you can just tell me in the comments. This is the condition. That is why we would be taking, in case of a tie, that is in the case when we have same elements, that is this condition equal to, the lower index element will obviously be in pq1, that is the front priority queue that we have. So we add cost of min priority, we update cost as basically the minimum element which is at the top of pq1, right? So we add that to the cost and pop the element from pq1. Otherwise, if the minimum priority queue element present in the pq2 is lesser than any of the elements present in this at the top of this, obviously we'll push that one to the cost and pop it out from the pq2, which is storing the back elements. And then when we have completed this while loop, right, the while loop after this one is completed, then we increase the higher plus plus, and finally this condition will terminate when we have actually reached our k sessions, that is k workers have been hired, and then we finally return the cost. So that would return our minimum cost, right? The total cost to hire exactly k workers, which is minimal and optimal. So that is the answer, and that's how you solve this problem.